Today we're going to learn about some standard circuit diagrams. Okay, so starting off from this side of the page, we've got a switch which is open and a switch which is closed. So the switch which is open is the breaking of the circuit because the current, the electrons, are stopped. There's a gap from this side of the switch to that side of the switch, so current is not flowing. But when the switch is closed, you have the little circles, they are flowing, and that is the making of a circuit. Electricity can flow as the current is flowing, and that's how you were to represent them in a circuit diagram. Okay, let's move on to Ohm's law number 2, where V is equal to IR. Ohm basically said that there's a relationship between the voltage, the current, and the resistance, and then he sort of represented it with a graph where the straight line represents the proportionality, and it's either the resistance as the gradient or 1 over the resistance. And these are the simple symbols which we can represent a voltmeter, which is just a capital V in a circle with 2 lines on the outside representing the wire. The ammeter, which measures the current, that's why there's a little A there. Voltmeter measures the voltage, that's why there's a little V there, or the potential difference. And then the resistor is just like a rectangle with 2 lines out. The line isn't going through, it's just on the outside. And that measures resistance, and that's why there's an ohm for resistance. Okay, moving on, we have some unusual symbols. Number 1, we have the diode, and it's like that start-stop symbol with a circle around and a line going through the whole thing. This is in forward bias, so it's moving that way. Reverse bias would mean that the arrow is going that way. Okay? And then you have an LDR, which is a light dependent resistor. You can say that it's a light dependent resistor because light is coming in through here, and that's the light dependent, and the resistor part is just a resistor here. And then you have a light emitting diode, so that's the arrows going away. So that's dependent and then emitting, and that's what an LED is, and that's what it stands for. So it's the same thing as a diode, it's a start-stop symbol with a circle, but just the emitting arrows. And then a thermistor is just a line through a resistor and then it gets saturated. These things are just best learnt by heart. That's how I did it in my GCSEs. But this follows on from that, and that follows on from that, and so does that. Okay, so moving on, we've got a variable resistor, same thing as a resistor, but just with an arrow through it. This arrow represents that the resistance can change. You can control the resistance, and by controlling the resistance, you can sort of change the current and the voltage using Ohm's law. V is equal to IR, because they're all proportional to each other. And then a lamp, I hope everyone knows a lamp is just a circle with a cross in it. It's pretty much a simple symbol. I don't know why that's the symbol for it, but it just is. And then we have a fuse. A fuse is sort of like a resistor, but it's got a line going through it. They're not the same thing. Notice the difference. The line going through it represents a wire. And when you have a circuit that has too much current flowing through it, a fuse sort of breaks the circuit and protects it. And it's done by this wire here melting it. So the wire here melts and breaks the circuit. Okay, so hopefully that makes sense. And then we'll have a recap on cell and battery. This is how you draw a cell, and this is how you draw a battery. A cell, it looks very similar to a battery, but it's like a single unit. A battery is made up of loads and loads of cells, and in your circuit diagrams in your exams you're more likely to have a battery than a cell, because batteries are better to use pretty much because a cell is only a single unit. Okay, now we're going to look at a thermistor and LDR. So thermistor and LDR in a little more detail, so a little more theory. So for a thermistor, it's a relationship between resistance and temperature. Okay, so as the resistance increases, the temperature is going to decrease and vice versa. So as the temperature increases, the resistance is going to decrease. And they're related by this proportionality. So let's say Y is resistance and X is temperature. If I increase Y, X is going to decrease. But if I increase X, Y is going to decrease because I'm dividing by a larger number. So that's the proportionality. Okay, so And that follows on to number 2, where if more current flows at high temperature, there'll be a lower resistance. So at higher temperatures, a lower resistance, so more current is going to flow. But at high resistance, less current is going to flow, and it's going to be a low temperature because, like I said here, that represents the current flowing. As more current is going to flow, there's going to be a smaller barrier, which is the resistance. But in this case, this is not a resistance, this is a switch, this is a different thing. But I mean by if this barrier is greater, if the resistance is greater, less current is going to flow. Okay, so now we're going to move on to an LDR. And an LDR stands for light dependent resistor, and this detects light levels, so it's pretty good for light sensitive devices to switch on and off depending on the light. And this is the same sort of proportionality here, where as resistance decreases, the light increases. So as resistance goes down, you'll have a higher level of light, so you'll have a higher light. But then in number 2, when you have dark low light, your resistance is going to increase, so little current flows. It kind of makes sense because when you increase your current, when you have an LDR, if you've ever done it practically, you'll notice that an increase in current makes the light go really, really, really big. And then as you decrease the current, you're kind of going to get a low dark light because the resistance for the low dark has increased and for the bright, the resistance has decreased. So hopefully that makes sense. That's just a recap on knowing your symbols. You're more likely to have questions on what this stands for, or can you draw this symbol, or using a battery and a voltmeter and a resistor to connect up a circuit and a bulb. So these are the symbols you should know. They're in the specification. Hopefully this has helped. If not, let me know. Cool. Thank you for taking the time out of your day to watch it. Bye, guys.